Exercise 2F question number 1a, y equal 3fx plus 2. So first of all, y equal fx, then y equal 3fx. So this is a vertical stretch, vertical stretch uh, with scalar factor, uh, scalar scale factor 3, and then y equal 3fx plus 2. Now this is a translation, vertical translation of plus 2. So y equal fx, we have points -2, 2, 3, 4, and 0, 0, and 3, 4. So this is the original graph fx. Then y equal 3fx, vertical stretch. So we have to multiply by 3 all the y values. 2 times 3 6, 0 times 3 0, 3 times 4 12, and x stay the same. Then y equal vertical translation, y axis, 3fx plus 2. We want to stretch, we want to shift this graph by 2 up. So it is affected. So in again it's effect to the y value. 6 plus 2 8, 0 plus 2 2, 12 plus 2 14. This is stay the same, and this is correction, minus, this has to be -2. 2 times -2 -6, -6 plus 2, that is -4. So this is the graph, -2 -4, 0 2, and 3 14. Y equal fx is the graph, part B. So y equal fx minus 2. So this is a horizontal translation of we want to shift 2 units to the right, so it is plus 2. And then y equal fx minus 2 minus 5. So this is a vertically we want to drag down. So this is a vertical translation. Vertical translation of -5. So y equal fx as usual, -2 -2 point and 3 4 and 0 0 and 3 4, and y equal fx minus 2, horizontally shift down its effect to the x values, -2 plus 2 0, 0 plus 2 2, 0 plus 2, I think this is 3 4, 3 plus 2 5. Then y value stay the same in here. Then y equal fx minus 2 minus 5. Then horizontal vertical stretch, we want to bring the graph, this graph by down 5 units. So this is become -2 -5 -7, 2 -5, and 5 4 minus 5 is -1. So this is -1. So this is the graph. Part C, y equal half fx plus 1. So then we want to first of all find fx plus 1 graph. So this is a horizontal translation of minus 1, and then y equal half a times fx plus 1. So this is a vertical stretch of scalar factor half. So y equal fx, we have the point minus 2 and 0 0 and 3 4. So y equal fx plus 1. So horizontally we want to stretch 1 unit to left. So horizontal mean x-axis. So minus 2, when you bring one more left, so it's become minus 3. 0 become minus 1 and 3 minus 1, 2. And y value stay the same. Now y equal half of fx plus 1. So this is a vertical stretch of half. So this is affecting to y value. So minus 3 minus 2 half it, now multiply by 2, multiply by half, or divide by 2, that is minus 1. Half a times minus 2 minus 1. So this is going to be minus 1 0 as it is. When you multiply by half, it is 0. And when you multiply by 4, it is going to be 2. So those are the new coordinates. So this is the graph. Part D, y equal fx graph. Then we want to turn into y equal f2x. So this is a stretch. This is a horizontal stretch of scalar factor of half. And y equal, before that I want just to revise, y equal half fx. So this is a horizontal stretch and the scalar factor is half. Y equal f2x, sorry, this is vertical stretch and this is horizontal stretch and scalar factor is half. So y equal afx. If it is a vertical stretch, the scalar factor is as it is a. If it is a horizontal one, if ax, the scalar factor is 1 over a. So that's what we learned earlier. So I revised this one. Then f2x minus f2x. So this is a reflection in the x-axis. So this effect is for y value. All the y value change the symbol of the y values. If we have a coordinate 3, 4 and let's say 7 minus 8, so change the value of symbol of y value. So 4 become minus 4 and minus 8 become 8. So this is called reflection. If it is like this, the graph, original graph, then minus become plus with the same, and plus become minus y value. So this is the reflection of this graph along x-axis. Fx is minus 2 to 0 0 and 3 4. So f2x is affect into the x value horizontal, so minus half times minus 2 times half minus 1, 0 times half 0, 3 times half 3 over 2, 3 times multiply by half 3 over 2. Y value stay the same, 0, and so this is minus 2. And then f2x then minus. So we want to change the y value, negative to positive, positive to negative. Minus 2 become 2, 0 as it is, and 4 become minus 4. So x is as it is. The graph is going to be like this. Y equal mod fx, y equal fx, and y equal mod fx. So the command is given in here is all the fx value put into the mod. It means turn into the positive. If you look at the graph like this, all the y values turn into positives. So then if the y value is positive, there is nothing to turn into positive, still positive it is. But if you look at this part and this part of this graph, so the y value of those parts are negative, then this has to be positive. So we can turn this y values into by positive, and as a result the graph is going to be like this. So if we have a mod, then above the x-axis the graph stay the same, stay the same. Graph below the x-axis, it's a reflection of x-axis. So that's the modus. So what is the difference between minus fx and mod fx? If it is minus fx, assume graph is like this. If it is minus fx, the whole graph turn with the mirror reflection along x-axis. So this part become here, and this part become here, and this part become here. So this is minus fx. But if it is mod fx, Whole top part is stay the same, and only this part is the mirror reflection. So here above the x-axis stay same. Below the x-axis, then reflection of x-axis. So y equal fx has -2, -2 and 0, 0 and 3, 4. So y equal mod fx -2, y value become positive 2, 0, 0 and 3, 4 as it is. Original graph is something like this. So the new graph is so this is the graph. We are expecting -2, 2 and 3, 4 and 0, 0. Part f. So y equal fx, then y equal f minus x. So this is a reflection of y-axis. And assume this is the graph. So reflection of y-axis mean this part is going to be, okay, let me change this one. This part is here and this part is here. So this is the reflection of y-axis. Then y equal mod f minus x. Above x-axis, stay same. Below x-axis, reflection of x-axis. So this is the original graph. Then reflection of y-axis. This part is going to be here. This part is going to be here. Now this is f minus x. Now I want to turn f mod. It means above the x-axis, this area stay the same. Below the x-axis has to be positive. So then this part, a reflection of x-axis, and this part also like this. Y equal fx, y equal then fx minus 2, that is the next step. So this is a translation or a horizontal translation. Minus 2, it means we have to move 2 to right, and then 3 times fx minus 2. So this is a vertical stretch of 3. O- Vertical stretch, scalar factor of 3. The points y equal fx minus 2 0 and minus 1 4 and 3 0 0 3. So then fx minus 2, it is affect into the x values minus 2 plus 2 0 and minus 1 plus 2 plus 1 and 4 as it is, 0 plus 2 2 and 3 as it is. Then y equal 3 fx minus 2. So y value has to be multiplied by 3. So 0 times 3 0, 4 times 3 12, and 3 times 3 9. So x as it is. So we will get this kind of graph. Part B, y equal fx, then y equal f half x. So this is a horizontal stretch. Scalar factor of 2, because 1 over half is 2, and then y equal half a times f half x. Now this is a vertical stretch, scalar factor of half. We discuss any stretch along y-axis stay the same. Any stretch along x-axis is going to be 1 over. That's why 1 half is 2. And the points are y equal fx minus 2 0 minus 1 4 and 0 3. Then y equal f half x. Scalar factor is 2. So we want to multiply by all the x values by 2. So minus 4 0, then minus 2 4, and 2 times 0 0 3. Then y equal half f half x. Then you want to take half of all the y values. So minus 4 0, minus 2 2, and 0 3 by 2. So this is the graph. Y equal fx, and then y equal minus fx. So this is a reflection in the x-axis. then y equal minus fx plus 4. This is a translation of plus 4. Um, y equal fx as coordinate minus 2 0 minus 1 4 and 3 0. Y equal minus fx. So this is a reflection. This is 0 3 point. So all so this is affected the y values. So this is as it is going to be 0. This is going to be minus 4 and this is going to be minus 3 and this is as it is x values. The graph is like this. So reflection of this one along x-axis mean this will go up something like this. Now this is shifted by 4 units up. So again it is effective y value 0 plus 4 is 4, minus 1 minus 4 plus 4 is 0, and 0 minus 3 plus 4 is 1. So we will get this kind of graph. Minus 2 for somewhere here. Part D. Y equal fx, then y equal fx plus 1. This is a translation along x-axis. With minus 1. Then y equal minus fx plus 1. Or we can work as this one, 2fx plus 1. And this is a vertical stretch of scalar factor 2, and then y equal minus 2 when you multiply by minus 1 fx plus 1. So this is a translation reflection. Reflection of x-axis. Fx we have minus 2 0 and minus 3 4 and 0 3. So f x plus 1. So it is affecting to the x value. So minus 3 minus 4, and this is become minus 2 0 minus this is 1 4. So minus 1 minus 2 and this is minus 1 3, and then 2fx. 2 times fx plus 1. So we are multiplying y value by 2. 0 times 2 0 This is 8 and this is 6, and this is stay the same. Then y equal minus fx plus 1 effect into the, so this is a reflection of x-axis, for it is affecting the y value. 0 is as it is, positive become negative, negative become positive, 8 is minus 8, this is also positive, so this is become negative, and this is as it is, minus 2 and minus 1. This is minus 3 0, this is minus 2 8, minus 1 minus 6 somewhere here. So this is the graph. Y equal fx, then y equal f mod x, then y equal to f mod x. So in here, x value less than 0, the area x value less than 0, we disregard. The graph we disregard. Area x greater than 0 we consider. Or you can tell that that is a reflection of y-axis. Now if we have a graph like this, so area x less than 0, so this is the area x less than 0, so this is the graph part, so we have to disregard. And then the reflection of y-axis, the rest of the graph reflection of y-axis. So that the task of a mod inside the function. If it is a sine graph like this, this is x sine x. So this is sine x. If we need sine mod x, what shall we do? So we want to select area x less than 0. Area x less than 0, this is the area. So this graph we have to disregard this side. Then the remaining part we need to take the mirror reflection. Actually, area x greater than 0. Reflection of x-axis, of y-axis. So this is the area greater than 0, x greater than 0 and equal. So we have to reflect this one on y-axis. That's the task. Then this is a vertical stretch of a scalar factor of 2. Now we have y equal fx minus 2 0 minus 1 4 and 0 3. Now mod fx, f mod x. So what we need to do now, any x values let's disregard less than 0. So basically this point we have to disregard. This is x values greater than 0. This is also x less. This point also disregard, and we can leave this point. Then y equal to f mod x. Disregard. So this is 2 times. This is going to be 6. The graph is original graph is this one. And then according to this one, we have to disregard the area. So less than 0. So we disregard now. So then take the mirror reflection. Area is greater than 0. So we have to reflect that one. Reflection on y of this area. So it is this one. So now this point is 0, 3. Now we have to stretch this one. It means this has become 0, 6. So the graph is going to be something like this.